Hi everyone, my name is Aslan, I'm an Android developer and today we will talk about object-oriented programming. Object-oriented programming, or OOP for short, is the most popular and main useful paradigm these days. This is primarily due to the fact that OOP is able to model almost any subject area. And in this video I will try to prove it to you with an example based on the story of Harry Potter. In our project we will use both the Java programming language because it is a very suitable language for demonstrating the possibilities of OOP, and the Kotlin programming language because I'm an Android developer. These two languages are mutually compatible, so all code that you write in Java is inside a class. A class is the template or some kind of blueprint from which objects are made. Let's pretend we are at Hogwarts and let's create a class to describe the students. The class consists of fields that form the state of the object and methods that allow you to operate on these fields. For example, a student has a name and an age, and we have a class student which have two fields, name and age. Now let's create another class to work on this class. Okay, this is public static void main. It is entry point of our program. So let's check how the program entry point works. As we see, the program is running. Now let's create some instances of the student class. This is declaration of object Harry. And this is initialization of this object Harry. Object declaration and initialization can be combined. This is for Harry and this is for Hermione Granger. Two objects. When we write a new, we refer to the constructor of the student class. Let's now specify the appropriate fields to distinguish between Harry and Hermione objects. We see two fields, first name, then age. The red underline indicates that we need a constructor. A constructor is a method that initializes the fields of the class when a new object is created. So the name of constructor and the name of the class is similar. In order to distinguish between constructor parameters and the fields themselves, the this keyword is used. So we have created two objects. Now we can extract and see some information from them. But what happens if we create another object, assign it a Harry object and change the age? As we can see, the age of the original object has also changed. This means that instances of the class Harry and Hermione actually only store references to physical objects in JVM memory. But before we talk about encapsulation, let's have a duel between wizards. For this we need to add a field of magical skills. And add levels for Harry and Hermione. And prescribe students the opportunity to fight in a duel. The logic of the function is as follows. Which of the duelists has the highest level of magic skill? That name is returned by the function. There may also be a situation where their skill is the same. Draw. Nobody won. Now, let's make Harry fight Hermione. We see that Hermione Granger won the duel because she has a higher level of magic than Harry. Yes, and it's time to talk about encapsulation. Encapsulation is hiding class data. We have already accessed the data of a particular object directly. But you can't leave it like that, since any class can change the open data, and with the incorrect data it's difficult to find the source of the error. It's necessary to hide access to data with the keyword private. And we immediately see the access error. To access or change a field with a private access modifier, we need to create getter and setter methods. Now, instead of direct access, we get a method that returns the required field. Okay, before inheritance, I'd like to show the possibilities of Enum class. Let's say we need to specify the faculty of the student. But when specifying, we can make a mistake. The Gryffindor with double fee and Gryffindor with a mistake. It is noticeable that a mistake was made in the name of the faculty. We know that there are only 4 faculties or houses: Gryffindor, Slytherin, Ravenclaw and Hufflepuff, so we can enumerate them in a special class. And now we can use this class whenever we need to specify faculty. So very well. Here we come to inheritance. Inheritance is the creation of a class from another class. And let's rename our student class to consider the inheritance mechanism. So we have a person class. It describes all the people living in Hogwarts because he names the fields name, age, and magical skill level, and houses, of course, faculty. But suppose that we want to create two more classes, students and teachers, and the students will have the same fields and methods as the person class. The same goes for teachers. And in order not to duplicate the same thing in new classes, in Java you can simply inherit classes. This is done using the keyword extends. Here it is important to design inheritance chain correctly. A student is not a teacher, but a student is a person and a teacher is a person too. In the Java programming language, in contrast to the C++ language, you can only inherit from only one class. And if you need to show common identical behavior in two or more classes, not always two or more classes, then you can create an interface. For example, we want both students and teachers to do something. We can create the same methods for them, but the implementation of these methods will be different. Let's create an interface with the method. Note there is no method body in the interface. Then implement this interface in our classes. Students will say, I study at Hogwarts school. Also, we can access fields. Enter the teachers. They said I'm Thus we come to polymorphism. We have the same method with different implementation. And when we run it, the compiler itself will determine which implementation of the method to choose due to dynamic binding. So Harry is a person and Hermione is a student, and let's create a new object, teacher. He was Severus Snape. Now we can run the corresponding methods. My name is Hermione Granger. We must and Snape. Do something. I'm Severus Snape and I teach children at school. We can't apply these methods in a person class because it doesn't implement interface some behavior. Harry is the instance of a person class. we can see this is mistake. But we can do the following. Make the person class abstract. This means that we'll not be able to create instances of it and we'll only use the abstract class to create other classes based on it. And these were Java classes, and we can easily use them in the Kotlin programming language. Okay, now as a final exercise, I suggest that you, together with me, develop an imitation of a duel battle between two teams of students. So, firstly, we will need a health field in the student class. Class student. Also need to add magic wand type. Let's create the select class with this name, which have two objects. There will be two types of wands, a Lavender wand and a Grigorovich wand. So let's create a set of spells for the magic wand.
Expecto Patronum!
Efficus Totalis.
Ridiculous!
Avada Kedavra.
Wingardium Leviosa.
So in this Enum class we have 9 spells. So let's create a method that returns a random spell. Thus, this method returns a random spell. Next, I want to create an interface for duelist. And the student class implements this interface. Note that we don't write the word implements as in Java, but simply put a colon as in C++. The logic of the attack is as follows. If the attacker's skill level is higher than that of the opponent, then he inflicts damage. Otherwise, the enemy blocks his attack. So we wrote the implementation of attack method. We can see, firstly checking this magic skill level greater than or equal enemy duelist magic skill level, then this logic. We counted total damage. It depends of type magic wand, Levander wand or Grigorievich wand, 20 or 30 in total damage. So spell itself values get random, and if spell is Avada Kedavra, then total damage 100, and if Curcio, this total damage is 16. Elsewhere plus 10 to this value, and of course the record in print line. This name attack the enemy duelist name with a spell. Enemy duelist take damage. This method, and elsewhere this magic skill level greater than or equal. It's not true. This false. If magic skill level less than of enemy duelist magic skill level, then we write in the console print line this name. Only try to attack. Not attacks are only try to attack. The enemy list, but the last is dodged. And this method subtracts the amount of damage from health. Override. By the way, in Java, if we override the method, we can denote it with the notation. Java package, student Java. This is notation. Override means that the method is overridden from the interface. And if we change its name to another method, the compiler will immediately start reporting this. And in Kotlin programming language, we specify the keyword override. We can also specify a default health value. It's assigned if we don't explicitly set it in the constructor. And let's create an instance for Draco Malfoy. So let's look at the health of Draco Malfoy before and after Harry's attack. Harry attacked Draco. So our program is almost finished. We just have to add a class for tracking the state of the battle and the class for the battle itself. Logically, two teams will participate in the battle. Each team member will duel a member of the opposing team until either team wins. So, there are 4 states of the game. Game in progress, first team won, second team won, game ended in a draw. And the battle class. We have team 1, team 2, and the boolean variable is game over. And let's create a team class. We need a team name and a list of students in that team. In the battle class, we will create three methods: get winner, get state, and start battle. And now we can proceed to the duel itself. And let's create two teams of 3 students. So now we can create teams. Let this team be called Cool Gryffindors. And the second team is Dark Slytherins. Next we create an instance of the battle class. And until the flag "Is game over" returns true, we will iterate the duel.
Boiling